Good evening, everyone. On the behalf of IEEE Chandigarh University Student Branch, I, Shruti Rani, here to welcome you all in the second day of the series workshop. IEEE CU is continuously giving the opportunity to everyone so that you can brush up your skills on a regular basis. So, if you are tech geek and you want your tech improvement, then you have to maintain your regularity in Tekaman 2.2. Now, we extend a warm welcome to the expert of the second day series workshop, Smriti Mishra. Ma'am is the head of artificial intelligence at Earthbank and computational neuroscience at KTH. Thank you, ma'am, for your valuable and precious time in second day event. Your presence in the event have leveled up the motivation not only for participants but for all the viewers who are watching it presently. Now the stage is yours, ma'am.
Thank you, Shruti. It's nice to be here with you again today. So yes, so Shruti gave an introduction of me, and I'm assuming that most of the people are the same, so I'm not going to introduce myself again. Um, like yesterday, I spoke about my work at Earthbank, which I cannot talk a lot about because we're working on it still. But today, I'll talk about my research at KTH and in another project that once I did for a couple of months, and in general, AI in neuroscience or AI and mental health. So I am a little sick and I did not get time to work on the presentation, so it's just something that is pretty basic, and I'll share the screen. And yeah, okay. Can you guys see my screen? Yeah, okay, I'm assuming it's possible. Yeah. So, so brain and AI, and AI and mental health. So, AI is closely linked to the human psychology. The basis for research in the field, it stems from the network of neurons in the human brain. These neurons make connections based on your perception and outside stimuli and transmit the information through electric and chemical signals, which allows adaptive learning to take place. Also, AI finds its primary objective in emulating human neurological functions, which basically mimics the way rational human thinking or rational human cognition takes place. So, given this, the complexity and scope are increasing rapidly right now in today's world when we have like more advanced AI or technological tools. So, from context awareness mechanisms, bringing out an ability to think and create a human like mind using things like natural language processing, which gives AI a platform and method to communicate. Every step, it basically is taken in the direction of making artificial intelligence fully analogous to human functioning and thinking. So, we know that so the first point I would like to discuss here is how we can use AI to classify mental health disorders better. So if basically what happens is if you have if anyone has a mental health disorder, it's most likely to overlap. So if someone has anxiety disorder, maybe depression, it's most likely to occur with the personality disorder. And the thing is that it's extremely difficult to distinguish between the two when it's overlapping because the symptoms might be similar. Plus, everyone's body responds different to the, any problem or disorder. And if someone's going through therapy or medication, in that case also it responds a lot different in each and every individual. So here AI can help. AI, if used correctly and cautiously, it is very promising in understanding the complex mental health diseases and even transforming mental health care. So AI can be very beneficial in predicting and classifying mental health disorders, as well as it will be beneficial in subgrouping them based on mood disorders, anxiety disorders, or if they're co-occurring, as I said. So also AI can potentially have higher accuracy as we keep developing more and more robust AI techniques or services, or yeah, whatever it is. It will be possible to help mental health practitioners to redefine mental health illnesses more objectively than it's currently done in the DSM-5. So also, it can help in identifying the diseases at a more earlier or prodromal stage when interventions may be more effective. And it can even personalize treatments based on individuals' unique characteristics, as the response often is extremely subjective, as I just mentioned. And obviously, this needs to be done with a lot of caution, and a lot of research is required for the same, a lot of conversations between neuroscientists and AI practitioners. Also, AI can help in reducing the stigma surrounding mental health, as it is still an issue that's frowned upon in a lot of parts in the world. When we analyze it using advanced neuroscience tools and AI, it might be sought after as a more acceptable thing in the society or something closer to a physical diagnosis. Yeah, okay, so I just answered that. I was quick. So AI can help understand our complex mind, which I definitely think. So in my experience, one of the biggest opportunities for AI in the field of neuroscience is doing more biologically plausible research and creating a visual perception of the unique features of the human cognition. So this will lead to us understanding and knowing so much more about the human brain, which is still a mystery right to this extent. So this will also eventually lead us in understanding mental health illness triggers and the best way to recover from them. Also, AI is closely linked to human psychology, the basis for research. Okay, I think I mentioned that. Yeah, so it eventually or essentially stems from neuroscience. So we can derive a lot of inspiration from neuroscience in the first place. And yeah, basically, neuroscience, as I said, has always been a key inspiration behind the history and development of artificial intelligence. And of course, there's a lot to learn from it still. Neuroscience can help make artificial intelligence more intelligent and more human like. So there are two key points to it. One is that artificial intelligence, it tries to replicate and or imitate the human intelligence. Now, with idea comes a structure in which you envelope your idea. And the second point is artificial intelligence or artificial network also tend to mimic the structure of the human brain itself. So transformations made using AI are breaking the internet right now, and we hear more reliable and accurate. We hear how reliable and accurate AI is getting, and however, there's still a lot to learn from there. It has already advanced quite a bit. So, as AI networks are inspired by the structure of a human brain, so are the neurons in the neural networks. So, the neural networks in AI have very similar characteristics when compared to the biological neurons in the human brain. The basic working mechanism is that when one neuron cell gets activated, it generates a spike and sends signals to other neurons. So, in artificial neural networks, which also has interconnected neurons, when a neuron receives an input, it gets activated and passes on the information to the other neurons. So basically, it works a lot similar to human brain than, I don't know, we might think, or yeah. So in a simple example, we keep getting better at a task that we do in real life. In a similar way, we train AI on a lot of data. Artificial neural network has X number of connections, and each connection on the neural network is associated with a weight. So this weight decides how much influence the input will have on the output. And we also have biases, which are constant and are an additional input in the next layer, and the value is always one. So during this entire training process, we tune the weights from node X to node Y as required. So during the training process, yeah, we tune the weight as needed, and hence, like as like we train it with more data, we adjust the weights, we adjust the influence, and this entire process, this entire iteration leads to us training the model better or having a more robust model. Or yeah, so it's essentially the same thing as human brain works. Also, there's a lot to learn about the plasticity and malleability of the human brain and try to implement that in the neural networks. It's an ongoing research to make AI more human-like, for the AI model to do the same task in a different environment. For example, me as a human, if I know how to learn how to play a piano, I can do it in the dark as well. But if I have an AI model which can play the piano, and then I have the same task, but in a new environment where the lights are shut off, so in that case, my AI model will not be able to do it as well. So there's a lot to learn, as I said, about the plasticity and malleability. And yeah, so, but it's going on, it's going good, I think. So yeah, so next I wanted to give a brief introduction about like why I would want to talk about mental health. So mental health is basically the, like, I wouldn't want to call it disability, but that's how it's looked at. So there are maybe 792 million people in the world who are going through some sort of mental health or substance abuse disorder, based on what, when I checked last, which was probably in June. And three-fourths of them are suffering in silence. So, why I think mental health is so related to AI is that, as I said, it's closely linked to human psychology. The basis for research is essentially inspired from the same place. So, there are a lot of ways in which we can use the combination of neuroscience or our knowledge of the human brain and AI in combination to help and work towards mental health. So, one example could be AI and anxiety. So, by the way, like the thing in the left, which is the from Rick and Morty, um, it 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 used to be me, or maybe still I am, like when I'm in public. So yeah, I basically die inside at whatever I say. I'm like, yeah, I'm like, why did I say that? So that's like a constant phase for me. So that's important to know. I think probably the most important thing I'll say today. So AI can help a lot with mental health issues or mental health problems. So, for example, when it comes to anxiety, it stems from amygdala, which is the fight or flight region of the human brain. And it's a very famous experiment where a mice was trapped inside a maze, and then they had like three different responses to it: fight, flight, or freeze. So, when anxiety is triggered and those anxiety hormones are released, it's essentially the fight, flight, freeze response. Although I probably fight or flight is like more common. So it essentially stems from amygdala in the human brain. So yeah, when it comes to detecting anxiety disorders or anxiety in general using AI, there has been a surge in AI based technologies which is aimed at diagnosing anxiety disorders. So scientists at the University of Vermont, they proposed a wearable sensor that monitors the presence of internalizing disorders, which is basically a group of disorders that includes anxiety. So traditionally, researchers monitor children's behaviors and responses to certain tasks designed to diagnose anxiety and depression. So not only this process is slow, but it's also less accurate. So when researchers tested this wearable sensor with, like, if I'm not wrong, 63 children, they noticed that the diagnosis was a lot more accurate. It was more accurate than 80% when infused with AI and used, rather than 68 to 75% when it's just the physical diagnosis. But what's even more impressive is the speed at which these disorders were identified thanks to AI. So the algorithm predicted the anxiety and depression within 20 seconds. The team is still finalizing on the tracker, but the initial findings are pretty encouraging, I would say. So, soon children could be routinely screened for internalizing disorder. Also, there are children below 8 years, and who go through anxiety, depression, and it's for them it's very difficult to communicate with professional. So something like this could probably help out in that thing as well. Also in New York, Charles R. Marmar, who's a psychologist and a psychiatrist and a researcher at the Department of Psychiatry in New York University of Medicine. He's been studying a lot on how AI can be used in post-traumatic stress disorder (PTSD) and war veterans. So the thing is, about 70% of adults in the US have experienced PTSD at some point in their lives. So traditional diagnosis is based on filling out questionnaires, right? Like as usual, like you answer the questions yourself about your mind. So the problem is that it's full of bias. It's often underreported or overreported, but most probably not accurate. So what these people do is they analyze speech to evaluate the speaker's emotional state. So they created a software which was uh, now the software they created was created with the help of a team that invented Siri, which is the Apple's voice assistant. So they used a range of speech-based features to train it. So they used supervised learning algorithm called random forest to classify the speech tone. So linked to changes in the brain functions, speech has shown to be an extremely valuable predictor of PTSD. So the software analyzes words in combination with frequency, rhythm, tone, articulatory characteristics of speech to infer the state of the speaker, including emotions, sentiment, cognition, health, mental health, communication quality, etc. So classification of PTSD candidates, it is impressively accurate at around 89%. So not only does the discovery cement the idea that speech could help diagnose PTSD, it also paves the way for AI to assist the diagnosis of anxiety disorders in the future. Also, the third point is like the therapeutic AI approaches for anxiety disorders. So once patients receive a diagnosis, they may be referred to a therapist or or may receive medication. But getting the treatment is a challenge as well. So this is a hidden disorder, and many patients find it difficult to communicate their struggle to the healthcare providers. So, for example, according to British Medical Association, it can take up to 2 years to be referred to a specialist in mental health issues in the UK. So, for example, there's a patient, and some of them they have to wait long time for really long time, and because they're not able to identify the difference between anxiety or feeling suicidal, and there are a lot of people who have unfortunately lost their lives to suicide because of that. I also spoke to Mike McCarthy, who's a journalist based in UK, and his son Ross. He took his own life, unfortunately, when he was 31 after struggling from depression for 2 years. And what happened with him was that he was diagnosed with severe depression and anxiety, I think. And then he was in a pretty bad state, and he was told by the healthcare officials that, like, go home, come back after 6 months. And that's when he could not take it. So, like, it can be an issue with accessibility as well. And accessibility is not only a problem in UK, it's a problem worldwide. Plus, you go to places where healthcare is not covered, and cost is another problem. It's extremely expensive to afford a psychologist or psychiatrist and get help for mental health. So computer and app assisted therapeutic tools have been around for years, but recently it was very unclear if they have made any difference. So do you think speaking to a bot could help us heal? So that is something that Northwestern University in US has been asking themselves, and they put an AI system to test. So the system or software called TESS, it communicates with the users who feel distress. So whether you're having an anxiety attack or would like to talk to someone, TESS is available for immediate support. So combining emotion algorithms with machine learning to analyze language, the AI can be accessed through Facebook Messenger or a third-party technology integrations. So to ensure that the help is adequate, it is maintained by mental health experts. It seems to be making a big difference. When students were given unlimited access to tests for 2 to 4 weeks, they said they felt less anxious compared to the students who are not using tests. So, I mean, we may think that, speaking to a bot may seem weird. But when people who have experienced it, they have, you know, um, they said that it was a lot easier to speak to the therapeutic AI as opposed to like a real person. So we associate IC indifference with automated chatbots. But most people, as I said, appear to be more accepting of the cognitive behavioral therapy or CBT delivered by a computer. What's more is that they often find it a lot easier to open up to an app as opposed to a psychologist. Another important thing to note is that none of these technologies claim to replace psychologists. It's just about breaking down barriers to entry and motivating those who find it hard to seek help to get help. So, although technology can provide relief in a moment, it cannot replace the face to face or medical therapy. So, this was pretty early, for AI to in the field of diagnosis and treatment of anxiety disorders. There are difficult tasks because each patient is different. Personalized therapy is a must. But bots and predictive diagnostic tools, they appear promising, and this may not work for everyone yet because you need enough data to train the things, and then yeah. So and it obviously would not replace conventional therapy anytime soon, but they will just play an increasingly important role in digitizing world, making it more accessible for people and maybe for self-diagnosis also. Sometimes it's a lot better than just googling a few symptoms on Google and assuming that someone's dying, because Google just leads to death. Basically, like anything, if you Google stomachache, it might lead to death. So yeah, so it's a lot better in that sense. Now another part is AI and empathy, like artificial empathy. So artificial empathy or computational empathy, it's a field of development of AI systems which can detect and respond to human emotions in a more empathetic way. So, empathy is basically the ability to understand or feel what the other person is experiencing by putting yourself or oneself in other person's position, and it can often be of different types. So, if anyone's wondering if artificial empathy is a good thing or a bad thing, if it's encouraging or terrifying, I would say that even though such technology can be initially perceived as threatening by many people, it has some very interesting use cases in the healthcare sector. So, from a caregiver perspective, for instance, caring for mental health patients is emotionally difficult for nurses and doctors. Doctors and nurses, they often report feeling burnt out, performing emotional labor above and beyond the requirements of paid labor. So this often compromises, or this may compromise, the quality of care. So AI robots, they can use empathy to care for patients maybe who are suffering from dementia, um, with and without feeling burnt out. So AI robots could use empathy to care for dementia patients without feeling burnt out, and they can go between nurses, doctors, and patients, if that makes sense. So they can basically work closely with doctors to gather information and refine the treatment process. So they can work with nurses to monitor patients and engage in day-to-day care. So in that sense, at the same time, dementia patients who receive constant empathic care report better outcomes, which is humanly not possible. So also according to emotional intelligence pyramid, which is there in the green thing like that, so the Maslow's missing apex of Maslow's hierarchy. So after the top hierarchy of self-actualization, there needs to be self-transcendence or emotional unity. Also, Maslow hierarchy of self-actualization represents the highest level or stage in the model of human motivation, the hierarchy of needs. So, according to the hierarchy of needs, self-actualization um, is something which drives us to realize our true potential and achieve our true self. Also, one important thing to note is that all the levels in the hierarchy have some sort of emotional intelligence associated with it. So there are three parts of empathy that describe empathy to us as human beings. It's cognitive empathy, effective empathy, and semantic empathy. When it comes to AI and moving towards more human-like intelligence, empathy will be essential. Since human intelligence is different from artificial intelligence, human empathy will be different from artificial empathy, and empathy can be learned, and AI can surely be equipped with artificial empathy in the years to come. However, it could be scary if not used cautiously. Therefore, ethics are extremely important when it comes to AI. Ethics in AI necessarily mean set values or principles and techniques which employ widely accepted standards of right and wrong and guide moral conduct in the development and deployment of artificial intelligence technologies. So, yeah, so as I said, it has pretty interesting use cases and definitely something that must be used in the times to come. And yeah, and I think that's all I have for right now. And we can do question and answers now. Okay, no, I have to. I always forget how to stop sharing screen in this thing. Yeah, I can't hear you, Shruti. You're muted.
Thank you, ma'am. Indeed, it was a great session. I truly believe that our participants have learned a lot from today's session. So now we will proceeding with the question in our chat sections. Ma'am, question that how can AI help to reduce depression, and do we really rely on AI to reduce on these things? Ma'am, unmute.
I'm muted now. Perfect. We are doing the ideal Zoom situation here. So, Siddharth, if you listen to what I said, and I think I said this three times when I was talking, that we cannot rely on just AI yet, or maybe in the times to come as well. So, we can't, basically. It's just, as I said, an entry point to understanding the disorders. And right now, we don't have enough data to train these models. We don't have, I mean, it's happening. You if you want to work with a product, you have to get a lot of people from different cases, like someone with depression, someone controlled, someone with some other disorder, and then you collect their data based on whatever sensor, whatever technology you're using, and then you train your model with it. So it's like limited, right? Like it's not something that can be used in every case as like right now. So the answer to the second part is not yet. I mean, we can't rely on it. We can, it could be a second opinion or a first opinion, and then you need a second opinion, but it's not something we can rely on. And I don't really know what you mean when you ask if it can be used to reduce depression, because it can't. I mean, but it can help to identify it, and it can help you or someone, like it can help people to get help when someone's depressed, and also it can help in better communication as something like as a therapeutic system. So we can understand a lot better, because often if someone's going through a lot, like severe depression or something, their family also goes through some sort of training. So in order to communicate more effectively with the person who's suffering, so and if someone's not aware of it, if someone's not into it, or someone doesn't know about it, then these therapeutic systems could help in better communication as well.
Yes, ma'am. Ma'am, is TensorFlow required for going ahead in AIML?
Yeah, it is. So it depends. Like I would say, in short, yes. And when someone works in a commercial environment or when you work with a company, they often use frameworks like TensorFlow. So it is absolutely required, not so much for research when you're building something from scratch, but for any commercial purpose, it's as long as I have used it in every single project. So yeah.
Yes, ma'am. Ma'am, what's the most popular language used in AI?
I would say Python.
Yes, ma'am.
Yeah,
Ma'am, is AI impact use on application development?
yeah, it is. I don't know what field of application development the person's talking about, but it is basically there in everything. Like, and if not yet in any field, it's going to be there very soon. Like right now, also as I yesterday mentioned, the whole climate change thing, we need to make things a lot more greener, and in order to do that, we need to implement. We need to first analyze what's happening, right? We need to first see what's our carbon footprint in each and every task. So, or your personal life, right? So it's basically going to be there in every single thing, and like analyze the data continuously, and so it's basically going to be there. Yeah.
Yes, ma'am. Ma'am, the next question that how close are we to achieve AGI?
So I don't think like the general. So right now, so okay, so we have three types of artificial intelligence. We have the weak AI, and then we have the strong AI, and then we have something that's better than human, like as close to human intelligence as possible. So right now, most of the AI is weak AI. Like if I train the model to just pick up a pencil, it'll just pick up the pencil, and it can't write without me writing another code and train the model to write the thing, right? Write anything with after picking up the pencil. So right now the model does only what it's instructed to do. So most of the models, like yeah, Sophia is awesome, and
Yes, ma'am.
it can sing and stuff, which is pretty cool. I mean, I can't sing, and yeah. So the thing with Sophia is it's extremely advanced, but that's not how most of the AI is right now, and most of it is still weak AI. For example, Siri, which or any virtual assistant which you use, they are also weak AI, and you'll know if you use Siri. It sucks.
Alexa. Yes, ma'am.
Yeah, it's like I try and ask Siri how to I shut my laptop down, and Siri does not know. So yeah, the thing is that most of the AI is weak AI, but there are some applications which are pretty cool. And for example, Py, that Python, no, the cheetah thing that MIT is working on, where the robot can do a backflip and all. And then there are some from Boston Robotics, which are pretty cool. And then yeah, there's a pretty funny robot. The robot is not funny, but the application it does, it's pretty cool but funny. So it's like this robot, I think it's called Tomatina, if I'm not wrong. It's from Japan. And you like put it on your shoulders, and then if you're like jogging or something, that robot basically turns its head and
Yes,
feed
ma'am.
you feeds you tomatoes. So I don't know. Yeah, I mean, yeah, they are pretty good applications, and yeah, so it's good,
Yes,
but
ma'am.
not.
Only because of AI.
Yeah.
Ma'am, what are the some of the best platforms to learn AI for a beginners?
Um, okay. So if you're talking about the course, then you find a lot of them on Coursera and Udemy and like all these places. And on Udemy, I think it's like always pretty cheap and good. And Coursera, you can always get it for free if you want by applying student aid, and which I always do still. So yeah, and then once you think you have a decent amount of understanding using those courses or something, then you can always, as I said yesterday, also go to Catet, Kaggle, etc., and just implement those codes.
Ma'am, can AI overtake humans in every field?
No, they can't. Should I explain more?
No, ma'am. Ma'am, being active on Kaggle and taking part in competition is necessary?
I haven't done that ever. I mean, I just did like one or two Kaggle interviews when I was applying for a startup. And the person, his name was Vladimir, something Vladimir Vladimir. So he was a developer in Google. So he gave me some problem that was, I think, from Kaggle, or it might have been Catet. So basically, it's not necessary to be in competitive coding in general, but it helps. I'm not from computer science background, so I did not do it as much, and but I wouldn't say it's like it obviously helps. Like the more you practice, the more you solve problems. It's the same, right? When we start walking or playing chess or cooking or anything. Like we just get better with practice. Something as simple as painting nails, we get better with practice. Okay, or it might not be that simple. I don't know. So, so yeah, it's not necessary, but it's good. The main point is that you understand what you're doing, and whatever it takes for you to understand what you're doing is good or important.
Yes, ma'am. Practice as makes us more perfect. Just like that.
Yeah.
Ma'am, next question that ma'am, tell me how cloud computing be good competition to the AI in future. Can you help me suggest which is secured?
Sorry, can you put it on the screen? Is it possible so that I can read it?
Yes, ma'am.
Yeah. Or if you just repeat it once more, that's also fine.
Yes, ma'am. Yes, ma'am. I repeat. Ma'am, tell me how cloud computing be good competition to the AI in future. Can you help me suggest which is secured?
What does the second sentence mean? Can you help me suggest future secure? Like,
Ma'am,
uh,
uh, like he asks that can you help me suggest which is secured about cloud computing and is it good competition to the AI in future?
okay,
Ma'am,
so
about cloud computing. Yes, ma'am.
yeah, so based on what I understand, um, cloud computing is necessary. I mean, we have a lot of data and we need a lot of data to train the model, right? So we need cloud to store the data, like for DBMS, managing data, like database structure management, like all those things. So we need cloud for that purpose, definitely. I personally do not work with cloud more than that. Like I have a basic understanding so that I understand how the data is stored, how we can pull the data out whenever we want. So for those purposes, and a good data platform, obviously, like cloud platform is obviously AWS, and there's like a lot of good resources out there for AWS. And yeah, like right now, I know some people in Accenture AI, Accenture Liquid Studio, and they are working. They have some good research going on in research, and they recently made cloud a necessity if you want to work with AI for them. So it's obviously important to know at least cloud, like at least understanding how it works and stuff. So I would say it's important, and it can be used with AI in a lot of ways. Like yeah, storing data. Like the thing is, with by 2030, we'll have a lot more data than we do right now. So it's like we already know that we'll have a lot of data, so the world is already getting ready for it. And yeah,
Yes, ma'am. Many more. Ma'am, how much mathematical knowledge is required to get started with ML?
to get started, you don't need anything. I mean, you can just learn as you go, right? So but ideally also it depends on what application someone wants to work on. If someone wants to be a data scientist, then they need a lot of statistics and probability plus good computational skills. If someone wants to be a data engineer, then they do not need a lot of statistics and like as much as a data scientist. So there are different applications in which the knowledge, the requirement may vary. Um, but when you want to get started, it's really not a requirement. I mean, it's the things that we can always learn. We have a basic understanding because we did it in school at least. And most of the colleges in India, they also have at least 4 courses in mathematics. So that is enough. And yeah, so that is enough in any case. And then if there's anything specific that's required, like for example, when you want to analyze how images work, you need to have an understanding of matrix and like yeah, all that. So those can be picked up easily. And if you do a machine learning course, they will have some mathematical concepts as well integrated in it. So you don't like need to have an explicit knowledge of anything in mathematics. It's something that you pick up simultaneously.
Yes, ma'am. Ma'am, what is difference between AI, machine learning, and deep learning?
So artificial intelligence is basically everything. So imagine like a huge big circle, and then machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So it's like artificial intelligence is like
Circle.
yeah, yeah, and then inside that is machine learning, and inside that is deep learning. So probably that's the easiest way to understand. And so artificial intelligence basically combines everything, like uh, artificial neural networks, pattern recognition, machine learning, deep learning, speech recognition, anything that you can think of. Machine learning combines the three algorithms: supervised and unsupervised, supervised, reinforcement learning, and all that. And then deep learning is what stems from machine learning as sort of an improvement of machine learning, which is based on neural networks. So anything that's neural network is deep learning.
Ma'am, question from Kalyanji that ma'am recently GitHub released GitHub Copilot on AI that can code itself. So my question is, are this type of AIs threat to coders, and will this AIs replace coders' job in future?
So no, I mean Satya Nadella also made it pretty clear that it is to make it easier for developers to code. But like you need someone to do it still, right? Like someone's writing the code, right? You have help, but you need someone who still moderates it or still does it in the first place. So also you can't like absolutely rely on it because it's just the you know it's not like for every application, and it's not as accurate as it sounds like. So yeah, also I'm not sure, probably a lot of people will use it,
Yes,
but I
ma'am.
find it pretty annoying that it keeps prompting the like what to do next. Basically it will not reduce the work. You still need the person coding to code, so it'll just make it easier ideally. I don't know how it's going to turn out in a few years, but right now no.
Yes, ma'am. Both are best on their stages. Ma'am, what should I have experience with before I start my AI journey?
um, I would say nothing. I mean, I I was doing EC, and then I started doing machine learning in my third year of undergraduate. And I mean, I don't think there's anything that you need before you start your journey in AI specific. I think I also answered this when there was this other question about how much information of mathematics is needed. So if there's anything, then it helps if you have a good understanding of mathematics or a decent understanding of coding. It helps, but it's not something that you cannot learn. But if you are someone who does not code at all, or someone does not who does not like coding at all, or has no idea, it will be a little difficult because you have to pick up a lot of things. But you can always learn. It's a pretty new field, and people have learned it recently. I mean, it started in 2014 or something, like data scientists, for example, data scientist's position or job. So it's a pretty new field, and everyone's learning it anyway. So yeah, it's learnable.
Ma'am, how? Ma'am, some films shows that robots will overcome man in all the fields. So that means we are under dangerous that robots can conquer us if we give them brain.
No, we have movies about zombie apocalypse also.
Yes, ma'am. Obviously not, ma'am. How does the work of data scientists differ from machine learning engineering?
So data scientist is more focused, as I said, it's combination of statistics, probability, some sort of environmental analysis or awareness. Then social skills also, like a lot of communication goes on, plus coding. So it's that, like it's like, and machine learning engineer, it sounds a lot more research oriented to me. And if you're talking about data engineering, then data engineering is more about the framework or the infrastructure, as opposed to a data scientist position, which is more about more solution oriented. Like you do the calculations there, and then data engineer takes care of more of the coding part and the infrastructure. So, either it could be that or a machine learning engineer, which would be like a lot more research oriented position, which would not involve a lot of real time statistics or real time probability.
Ma'am, can you explain how AI is so accurate on the obstacle, avoiding and damaging management in the process of automation? Like of we have machines which are so accurate human safety avoidance.
So, accurate on the obstacle avoidance. So this is actually an application of computer vision. So you like detect objects that's there in front of you, and it's basically a simple detection problem, and then you use it with a lot more advanced tools to make it better. And the more data you feed it on, the more you train the model, the more you tune the hyperparameters, the more you manage weights, etc., the more accurate it gets. But it is an application of computer vision, and it's a pretty widely used application also. So if you want, I can send you some papers around it, and yeah, it's basically used a lot. Like it's used to monitor accidents. It's used for, like, detecting the number plates in an accident. It's used for object detection. It's used for collisions. Like, it's used for a lot of
Recognitions.
applications. Yeah.
Yes, ma'am. Last but not the least, that ma'am, I want to learn computer vision. Can you please suggest me some good courses?
I think there are a few. I don't remember the name of the courses right now, but I did one which involved computer vision and robotics. So yeah, I can send the link. I don't remember the course. It was in Coursera. It had like half of computer vision and 60% of computer vision and 40% of robotics and detection and all that. So I can share the link after I check it, or you can maybe see it on my LinkedIn profile if I've added it. Yeah.
Thank you so much, ma'am, for giving such a great session.
Thank you.
Thanks a lot, ma'am. Indeed, it was a wonderful session, a day of two days journey where people have learnt a lot from you about AI and its future. And I believe that AI is having ample amount of opportunities in coming days. So thanks a lot to you, ma'am, for this wonderful session. Thanks to all the participation. So for this wonderful session, ma'am, we are having a small token of appreciation for you. Let me share the screen. I hope my screen is visible.
Yeah, it is.
Yes,
Thank
visible.
you.
So thank you, ma'am. This is small token of appreciation for you for this wonderful session of 2 days. It was really great session and mind blowing sessions. We had good amount of participation and good amount of questions too. So thank you for answering all the queries.
Thank you. I just realized how
Thank,
different I look. with long hair and short hair.
Exactly. You look awesome, ma'am, definitely. And
Yes,
the way
ma'am.
you delivered and the way you explained, that was really, really great. So thanks a lot to you. Thanks a lot to all the participants. We'll be sharing the feedback form in the chat section, and also we'll be mailing the feedback form to you all. So thanks a lot to all the participants. But it's not the last session. We are having many more sessions in Tekama 2.0. So keep joining us. Do subscribe our channel. Do like our channel. We'll be bringing many more good speakers as we had today. We have also shared the feedback form in the link in the chat section. So do fill that feedback form. So at last but not the least, thanks a lot to everyone. Thanks a lot to you, ma'am. Bye bye. Have a nice day.
Thank you. I also spoke to
Thank you,
Praveen
ma'am.
about it. Praveen Purushottam. Yeah. He's like, are
Yeah,
you there?
you
But yeah, I heard you were there.
great, ma'am. Great to hear that we are having so many good speakers with us.
I
So
met him when we were both judging the hackathon, Hack the Mountains, and that's how I
oh,
met him. And he's so cool. He's awesome.
exactly, definitely, he's also one of the good speakers we had. So
Awesome.
we'll always be bringing good speakers for you. Also, don't forget to subscribe and like our channel. Thanks a lot. Thanks to everyone. Have a nice day.
Thank you. Bye.